All right, ladies and gentlemen, here we are for the week 22 test. Now, in this first problem, you're being asked to do some statistics. And the idea, they call this surveys and samples. The idea is you're trying to figure out what is the best way to sample a group and get what we call a representative sample. And a representative sample means the sample represents the group as a whole. So if you had 1,000 people and they were the group as a whole, and you said, well, I wonder what the favorite flavor of ice cream is for that 1,000 people. I can't ask them all. Let me see if I can find a representative sample of 50 people. And I'll ask those 50 people their favorite ice cream. And whatever the favorite is for those 50 will be the favorite for the 1,000. Because I know that 50 represents the 1,000. So this first problem, you can see a local store wants to survey their customers about why they shop at the store. And they come up with 4 different ways that they're going to conduct the survey. Your job is to figure out which of those ways is representative. So survey every 5th customer during checkout. This is choice A. That's a really good way to do it. You get a random sample of the people. So maybe the 5th customer is a grandma. Maybe the 5th customer is a 12-year-old buying a Snickers. Maybe the 5th customer is a lady with 3 screaming children. Maybe the 5th customer is some guy on his way home from work. Every time the 5th customer, the next 5th customer comes through, you ask that person, why do you shop at the store? That should be a good sample. The second one, survey every customer that lives within 1 mile of the store. Well, you know what? There's a problem there. The problem is you're asking a group of people who have a certain common characteristic. These are all people who live near the store. So you might expect, well, maybe I'm going to hear they shop at this store because it's close. Well, that doesn't really tell me a lot about why people in general shop at the store. Unless I'm thinking that a whole bunch of people are going to move close to the store, that probably isn't going to help me figure out how to get more customers. So B is not a good choice. C, survey every customer during the 1st and 4th 10-minute time frame of every hour for a week. So let's say your store opens at 8 in the morning and closes at 9 o'clock at night. That's Trader Joe's, keeps those hours, 8 to 9. So that means from 8 to 8:10, you're going to survey everybody in the store. And you're going to do that again from 8:30 to 8:40. And then you're going to do that again from 9 to 9:10 and again from 9:30 to 9:40. And you're going to do that throughout the entire day. And then you're going to do that for the whole week. So weekdays, weekends, morning, middle of the day, nighttime, that's going to give you a really good representative sample. Again, as long as you try to survey everybody who's in the store during that time. So C works. Finally, D. Set up a booth in front of the store where the customers who want to participate can come, and those who don't want to participate don't have to come by. Well, anytime you're looking at sampling, there's a bias when you get only people who volunteer, only people who walk over to where you are. Again, they may not represent everybody. Maybe these are people who they're just happy to see you, and they're going to tell you whatever they think you want to hear. So you really don't look at that as being a good sample. All right, so let's move on. Question number 2. Question number 2, they give you a sampling. They told you that there are 60 students from the middle school that were surveyed. That doesn't mean the whole school is only 60 kids. It means they talked to 60. And they got the results for the question, what's your favorite subject? And you can see the table. 12 picked English, 16 picked math, 10 picked science, 8 picked history, 14 picked PE. Notice again that they make the statement, this is a representative sample of 60 students. So they're telling you they already went through and they figured out how to get a mix of students. Maybe they had 5 kids from every first period class or 5 kids from every 4th period class. They didn't just go and ask 60 students all standing together. They didn't just go out to ace badminton and say, oh, there are 60 of you here in the gym. What's your favorite class? So then they give you 3 statements, and you have to decide, is that statement true or is it false? So the first statement they make is this: PE is the favorite subject of more students than anything else? Well, look over here. Here's our table. PE, it did get 14 votes, but look here, just like we'd expect, math got 16 votes. Math is the bestest. So A is false. Math is the favorite for 16 students. PE only got 14. Second question. Twice as many students picked math compared to history. So let's get rid of those highlights and let's look at this next. Twice as many picked math compared to history. So here's math again, 16 students. Here's history, 8 students. Yes, that's a true statement because 8 times 2, and whenever you're thinking of twice, you're thinking of times 2. 8 times 2 does equal 16. So that one works. All right, third one. In a group of 300 students at the school, it's expected that 48% of the students would pick math as their favorite. So we need to do a little work here. On our original survey, here's our original survey right here. Let me change that up to a color that's a little bit brighter. Right here's our original survey. 16 out of 60 picked math. So when we do that, 16 divided by 60, we get 0.26 repeating, or about 27%. Now, their statement is 48 students would pick math out of 300. So we do the same thing. We do exactly what we did. We do 48 divided by 300, and this time we only get 0.16, or 16%. That isn't enough. So we can make this statement: 16 over 60 does not equal 48 over 300, and then the extension is right here. 16 over 60 would actually be 80 over 300. 60 times 5 would give you the 300. So if we did this, and we said, okay, right here, 60 times 5 gives us 300. So if I bring that idea over, 60 times 5 is 300. So 16 times 5 is 80. All right, let's move to the back of the test. So here we are on the back, and we're doing a volume problem, the volume of a triangular prism. So anytime we're doing volume, here's our formula. The formula is always base times length equals volume. So base times length equals volume. So the first thing we're going to do is we're going to find the base. And in this case, since it's a triangular prism, the base is right here. It's a triangle. So when we get the area of that triangle, this is our formula for the area of that triangle. 6 times 5, base times height divided by 2, which is 30 divided by 2, which is 15. We take that 15, there's the triangle right there, and we multiply it by the length, by the 11, and we get a total of 165 cubic centimeters. So it's always base times length is equal to volume. All right, number 20. So here's all of our work for number 20. This is a surface area problem. When you're doing surface area, remember you're counting all of the faces and you're adding the area of each face together, and that gives you your total. So for this triangular prism, there are 5 faces. There's this triangle, and there's another triangle that looks just like it. That takes care of 2 of our faces right here. Then we have this face on the bottom. There it is. And finally, we have this side and one more just like it. There it is. And then we go through and we find the surface area by getting the area of each face. So for the triangle at the end, 10 times 12 divided by 2 equals 120 equals 60. There are 2 of those, so we have to do 60 times 2. For these sides, there's one on this edge, and there's one on the other face. The other face would be this side right here. This side kind of in back right there. So that's 15 times 13, 195, 2 of those. And then for the bottom, 15 times 10, and there's only 1 of those. Add those together, we get 660. For the second part, we have to go through and we have to do the faces again. Now this is a rectangular prism. So the great thing about a rectangular prism is there are 3 pairs of faces. So this is a pair that's 6 by 7. That's this bottom pair right here, 6 by 7. Then there's another pair, a base of 20 and a width of 6. So there's 2 just like that, 6 times 20s. And there's this edge, which is 20 times 7. And there's 2 of those, 20 times 7. We multiply each of those out. We double them, because there are 2 just like it. We get our 604, and then we're adding them all together, and we find out that the triangular prism at 660 centimeters squared is a little bit bigger than the rectangular prism, which was 604 centimeters squared. All right, there's the extra credit. It's a surface area problem again. You can see all those parts. You might want to pause the video and redraw this shape and then solve it again and see if you get the same 328. All right, so that should set you up for this week's test. And remember, this is something you can use to study from, because right here you have 21C. And if we keep working our way up, let me get it scroll just right. 21.1, excuse me. So there are 2 different concepts, then concept 22.1 and concept 22.2. So if you decide, hey, I want to take some intervention tests, studying these past tests is a good way to study for those interventions. All right, great. As you have more questions, feel free to bring them to